1 liter water is there with you. Its temperature is 4 degrees Celsius. And we have to find out number of molecules present in that 1 liter water at 4 degrees Celsius. I am revising the sum. We have to find out number of molecules present in 1 liter water, but temperature of that water is 4 degrees Celsius. Can we find out number of molecules? Answer, yes. Let us start one by one. So first part, that is why temperature is mentioned. Because here definition of one of widely used unit, but it is not SI unit is there. That is 1 liter. Actually you are aware SI unit of volume is meter cube, decimeter cube, centimeter cube, millimeter cube. Like that it should be in terms of millimeter, centimeter, decimeter, meter, cube. Anyway, but here worldwide we are observing liter as important unit in terms of measuring liquids. So definition of 1 liter, that is volume occupied by 1 kilogram water at its maximum density. You are aware water is having anomalous behavior. Density of water is maximum at 4 degrees Celsius, and therefore here volume occupied by 1 liter water at 4 degrees Celsius. That volume is volume occupied by 1 kilogram water at 4 degrees Celsius is considered as 1 liter. So it's very clear from this definition that you have provided 1 liter water having temperature of 4 degrees Celsius. That means the mass of that water is 1 kilogram. That is 10 raised to 3 gram. Clear? So first data I will write here, that is W, that is equal to 1 kilogram, or rather 1000 gram. Now molecular weight of water, we are aware as formula is H2O. Its molecular weight is 2 plus 16, that is 18. Now third thing we have to do, that is N. What is N? N is number of moles. How to find out number of mole? So number of mole equal to W, that is given weight upon molecular weight of substance. So it's 1000 upon 18. You are aware of table of 18, so I can straightway go this way. 18 ones are 18 fives are 18 fives are 90. Carry forward 10. Again 100, so 55. Again carry forward 5, and like that you can go recurring 555. So I must round up here 5 at 6. Keep in mind here rule is there. While teaching only or while solving the problem only, I will teach that rule, how to round up. Let us take certain figures to round up. Say for example 6.667. Second figure 6.665. Third figure 655. Third figure, fourth figure 664. How we are going to round up till 2 decimal. So here, as I have to round up last digit. So we have to check last digit is greater than 5 or less than 5. As this digit is greater than 5, I have to add 1 to the previous digit. So this can be rounded up as 6.6 and 7, because the last digit is greater than 5. So I have added 1 to here and answer is 6.67. Now suppose I have to round up to 1 decimal only, then obviously last digit is greater than 5. So I will add here and this answer will be 6.7. So I may write here also, this I can round as 6.7 for 1 point we can go. Now here the last digit is 5. Now observe both the cases here and here. Last digit is 5. If last digit is 5, then we have to check previous number. If If previous number is even number, keep it as it is. So this I can round up at 6.66. Now for one decimal, so this number is obviously greater than 5. So I have to add 1 here. So this will be again 6.7. Now here also end digit is 5, but previous number is odd. If previous number is odd, then we have to add 1. If previous number is even, keep it as it is. This will be only if last digit is 5. Then obviously this answer is 6.6 and I will add here, so 6. And again this will be same as 6.7. The last thing, last digit is greater than, less than 5. It is not equal to 5, not greater than 5. It's less than 5. So keep previous digit, whether it is odd or even, as it is. No change in the previous digit. So this way, and this can be also round up as 6.7. So these are the rules we are using to round up the figure. You can take it down for example. So according to this, this is 5.5555. N number of times you have to write 5. So I will round up and say it is 6 because last digit is 5. We have to add 1 digit to to the previous digit. And this way we have written here N, that is equal to 55.56. Now, what is the solution? 1 mole of any substance corresponds to 6.022 into 10 raised to 23 number of molecules. Therefore, 55.56 mole, because we have calculated number of mole, corresponds to what? And then this divided by this multiplied by this. So answer is 6.022 into 10 to the power of 23 divided by 1, obviously multiplied by 55.56. So we are getting answer, that is the multiplication of these two figures and to the multiplier of 10 raised to 23. So I hope you are able to do this calculation. This is the multiplication you can do at yourself, or else I have to show here. I will show. I will write 55.56 multiplied by 6.022. So school days method only we are going to apply. So forget of decimal and carry out calculation first. So 2 6s are 12, carry forward 1, 2 5s are 10 plus 1, 11, carry forward 1, 2 5s are 10 plus 1, 11, carry forward 1, again same, write it down as it is. Forget of decimal while calculating. Now this second 2 I have to multiply, so I will put 0 here and then multiply, but multiplication will be same. As we are aware that same figure. Now I have to put 2 zeros. No doubt, I have to multiply by 0 only here. But still, I should not forget to put 2 zeros over here and then multiply by 0. So everything is 0. But I will keep digit as it is. And now 6. So I have to put here 3 zeros. And now multiply. 6 6 are 36, carry forward 3. 6 5s are 30 plus 3, 33, carry forward 3. Again same 33, carry forward 3 and 33. 2, 3, 2, 2 plus 6, 8, 5, 4, 3, 3. And what is the rule? Decimal after summer. So here after 3 places, here after 2 places. So decimal should be given after 5 places. So from here 1, 2, 3, 4, 5. So our answer, I will write here 334.58232. This is just I have shown multiplication of 6.022 into 55.56 multiplied by 10 to the power of 23. These many number of molecules are present in 1 liter water at 4 degrees Celsius.
Pause this video and scan QR code for more information.